Hi there, thanks for clicking on and watching. Welcome to this video. Hopefully you've done so because you are either in the lower six or the upper six and you would like to revise and further your knowledge of the binomial expansion. So this is the video for you if that's the case. So we're going to go through the basics and then take you through some exam questions as well. So let's get started. So the binomial expansion is used to expand when you have just two terms because it's by in a bracket to a power. So just looking at these here, a plus b to the 0 is going to be 1, a plus b to the 1 is just itself, and then a plus b all squared will be a squared plus 2ab plus b squared. So noticing whatever the power is, you get one more term. So when the power was 2, we get 3 terms. So if we do a plus b cubed, we're going to expect to get 4 terms. Now we've just found what a plus b squared is. So if I write that out in the expanded form, and then to get a plus b all cubed, we would just times it by another a plus b. So multiplying through by a, we would get a cubed plus 2a squared b plus ab squared. Then multiplying through by the b, we're going to get a squared b plus 2ab squared plus b cubed. So we need to tidy up to get our 4 terms. We're going to have a cubed plus 2a squared b here and another one, so 3a squared b plus an ab squared plus another 2ab squared, which is 3ab squared plus the b cubed. So what do we notice about what's going on? The powers in the a, which was the first term in the bracket, are coming down. We've got 3, 2, 1, and then here we've secretly got a to the 0, which is 1, so we've just got our b cubed. The powers in the b are going up, so here we can think of b to the 0, we've got b to the 1, b squared, and then b cubed, so the powers in the b are going up. Now each term in the binomial expansion does have 3 parts. You can see you've got a coefficient, a power on the a, and a power on the b. So noticing that the 2 powers together, they add to give you the power on the bracket. Now it's just this number in the front that we need to explain, and the coefficients, the numbers in front, come from Pascal's triangle. So the expanded bracket we just looked at was a plus b all cubed, and whatever expansion you're trying to do, the power on the bracket is going to start on Pascal's triangle with 1 and then that power. So we just did a plus b all cubed, so that's going to come from the row that starts 1, 3. So if we just do a plus b all cubed, it's going to be a to that power on the bracket plus, and then you get the coefficients from Pascal's triangle, 3a squared b plus 3ab squared plus b cubed. So again, we've got 4 terms because the power in the bracket is 3. You always get one more term. The powers on the a are descending, the powers on the b are increasing, and the powers on each term of the a and b are going to sum to the number on the bracket. So if we wanted a plus b all to the 4, we would be using Pascal's triangle that starts 1, 4, and we'd be writing a to the 4 plus 4 a cubed b, the powers in the a are going to come down, plus 6 a squared b squared plus 4 a b cubed plus b to the 4. Now noticing we've got 5 terms now because the power is 4, and those coefficients are coming from Pascal's triangle. Now if you look at the middle terms, they have all got 3 parts. They've got the coefficient from Pascal's triangle, they've got an a to a power part and a b to a power part. Now secretly, the first and the last parts, they also do have 3 parts. So if you just think of that a to the 4 and the 3 parts, it's got the coefficient from Pascal's triangle, which is 1. And really, to get these powers on the a and b to add up, it's b to the 0, which is also 1. So we don't normally show the 3 parts because we always know that it's going to be a to the 4th, the other parts are 1, and then at the end, similarly, the 3 parts for our b to the 4, we're going to have a to the 0, and then again, our coefficient for Pascal's triangle is going to be 1. Whenever you're doing a binomial expansion question, you get this here from the formula book, and you can see this notation here is what you are going to use in order to find the coefficients that you would get from Pascal's triangle. So this bracket notation just means we're going to be using the NCR button, and you can find that on your calculator by doing shift and divide. When you press that button, your calculator is performing this operation here. So if I wanted to do, for example, 5c2, you would do 5, shift and divide, and then 2, and your calculator would be doing 5 factorial over 2 factorial times 3 factorial. So anything factorial, for instance, 5 factorial means 5 times 4 times 3 times 2 times 1. So all the numbers times by themselves all the way down to 1. And how this operation works is the two numbers on the bottom have to add together to give you the number on the top. So if we just have a look at the a plus b all cubed that we were just looking at, that was a cubed plus 3a squared b plus 3ab squared plus b cubed. So these coefficients, which came from Pascal's triangle, 1, 3, 3 and 1, we can get them using this NCR button by doing 3c0, which is going to be 1, 3c1, 3c2 and 3c3. So we always start with the NC0, then we're going to count 1, 2 and 3, and by the time we get to the end it's going to be NCN, and they are always going to be either end ones, and we know that from Pascal's triangle we have to end the beginning and the end is always going to be a 1. We can see again powers in the A's are going down, powers in the B's are going up. So let's have a go at this example here. So it's to the power 4, and what we've got to remember, instead of just having a single term like b, we've got all of this here, 2 terms. So whenever we're going to be raising b to a power, we have to include the 3 as well. So the coefficients we're going to get from Pascal's triangle are 4c0, 4c1, 4c2, 4c3 and 4c4. So remember, each term is going to have 3 parts. So if I just put them in columns here, so we're going to have the coefficient from Pascal's triangle, so that's going to be the NCR coefficient. We're going to have the A coefficient, or the A part of the term, and then the B part of the term. So 4c0, Pascal's triangle always starts with 1, and then we're going to have 2 to the 4, and we're going to have b to the 0. Then we're going to have 4c1. Now Pascal's triangle, whatever power you've got in the bracket, that row of Pascal's triangle starts 1 and then 4. So 1 and that number on the bracket. So this is going to be 4. 4c1's 4. And then we're going to have 2 cubed. And then we're going to have 3x to the 1. And then the next term, 4c2, is going to be 6. We're going to have 2 squared. And then we're going to have 3x all squared. And then we're going to have 4, 2 to the 1, 3x all cubed, and then again we're just going to have our 1, 2 to the 0, and then 3x all to the 4. I wrote b then, it should have been really 3x to the 0. So now tidying up, we know for the first and last you're just going to get that a to the power and then the b to the highest power, so it's going to be 2 to the 4, which is 16, and then plus, and we just have to times all these together. So 4 times 2 cubed, which is 8, times the 3 is going to give you 96x. And then we've got 6 times 2 squared times 3x all squared. So that will give us a 9 there. And that gives you 216x squared. And then the 4 times the 2, which is 8. 3 cubed is 27. 27 times 8, 216x cubed. And then the last term, 3x all to the 4. We've got a 1 and a 1 again, so that's just going to give us 81x to the 4. So thinking about each term having 3 parts, of course the first and the last, you're just going to get the term in the A and the term in the B. Okay, so let's have another look at another example, 1 minus 2x all cubed. So this is somewhat easier because you've just got this 1. So whenever the A term appears, you're going to have 1 to a power, and that's just going to be 1. We're going to get our coefficients from Pascal's triangle, which we know are 1, 3, 3, and 1. So if we just think of all our terms, we're going to get 1, 3, 3, and 1 from Pascal's triangle. Now the A to the power term is just always going to be 1. So we can just write 1 in all of those. And then we're going to get the minus 2x. So that will be our B term. Now this one will be minus 2x to the 0. And then we'll have minus 2x to the 1. Minus 2x all squared and minus 2x all cubed. So tidying up this one, we're just going to get 1, and then 3 times minus 2 will give us minus 6x, and then here, because we're doing minus 2 all squared, that's going to give us a plus 4 times the 3 is going to be plus 12x squared. And then this last term, we're just going to get minus 8x cubed. So you can see when you've got a minus here, and as you're going down your terms, when you're going to raise that B term to an even power, the minuses are going to cancel. So when you've got that B term raised to an odd power, you're going to get a minus. So whenever you've got a minus in the brackets, the expansion is going to alternate between plus and minus. Now this is a question where we've got to go to a particular term in the expansion. So if you're feeling confident and you feel like you've seen enough to revise the binomial expansion, pause the video, have a go at this question yourself, and then press play and watch, or just continue to watch when we explain this one as well. So if we just look at the A plus B all cubed that we've just had to begin with, so we had A cubed plus 3a squared b plus 3ab squared plus b cubed. So again, thinking about the 3 parts to each term, this 3 comes from 3c1, a squared, and then b to the 1. Now the 2 powers on the A and B have to sum to the 3, and the power on the B is the same as the number we put at the bottom when we're doing NCR. So this question says the coefficient of x squared in the expansion 2 minus cx all to the 5 is 720. Find the possible value or values. So here's a big clue that there's maybe going to be more than one answer for the constant for c. So because we want the x squared, so how are we going to get the x squared? It's going to come from this when we square it all. We've got to bear in mind that it's minus and it's got that c. C is just a constant, so it's minus cx all squared. So this is going to tell us that we will then have this term will be 2 cubed because the 3 and the 2 have to sum to the 5 on the bracket, and then we're going to have a 5c2 because this number here needs to be the same as the power that's on the b term, which in this case is minus cx. So all this we can put in our calculator here. So 5c2 is 10. 2 cubed is 8, and because we're going to be squaring all of this bracket, it's going to be c squared x squared times there. So 10 times 8, 80 c squared x squared, and it's telling us that the coefficient, which is all this in front of the x squared, is equal to 720 x squared. So 80c squared must equal 720, so then we can just solve for c. So c squared is going to be 720 divided by 80, which is 9, so c can be plus or minus 3. So here's another example similar to the last one. So you can pause the video and have a go, or just continue to watch to get the solution. 2 plus kx all to the 7. So we only asked for the first 4 terms, and so the first term is going to be 2 to the 7 plus, and it's going to be 7c1 times 2 to the 6 times our kx. So whenever I've got something that contains two things multiplied together and maybe the sign here, I use brackets to remind myself to raise it to a power. Now the 7c1, Pascal's triangle, always starts with 1 and then n. So we always know that the second term, the coefficient using the NCR button, is just going to be the number n. Now if you think about 7c1, it's actually 7 factorial over 1 factorial 6 factorial. Remember, the numbers on the bottom complement to the number on the top. So what your calculator is doing 7 times 6 times 5 times 4 times 3 times 1, but that is 7 times 6 factorial instead of writing them all out, divided by 1 factorial times 6 factorial. Now you're always going to get that 1 down factorial, and because you've got 1 here, that's always going to be 1, and then these will always cancel. So whenever you've got anything C1, it's just always going to be that number itself. So we know 7C1 is going to be 7. So let's carry on. We're going to have 7C2 times 2 to the 5 times kx all squared, and then 7c3 times 2 to the 4 times kx all cubed. Now it only wants the first 4 terms, so we can stop there. 2 to the 7 is 128, 7c1 as we've just discussed is 7, and 2 to the 6 is 64, so 7 times 64 is 448 kx. 7c2 on your calculator is going to be 21, 2 to the 5 is 32, and 21 times 32 is 672, and then that will be, you have to remember, this is why we use the brackets, to square the k and the x, so that will be k squared x squared. Then the last term, 7c3 on your calculator is 35, 2 to the 4 is 16, 35 times 16 is 560, and then always remember you've got to cube the k as well, so that's k cubed x cubed. Now for part B, given that the coefficient of the x cubed is 1890, so what is in front of the x cubed? It's all of this in terms of k, so we know that 560 k cubed is equal to 1890, and we can just solve for k. So 1890 divided by 560 is going to be 27 over 8, which are both cube numbers, so k is going to be 3 over 2. So here's another exam question. Pause the video and have a go, or just continue to play it and watch the solution. So for part A, find the first 4 terms of this expansion. So I'll just do that here. So it's really easy when you've got 1 in the A position, because every time that A comes into the expansion, 1 to any power is just going to be 1. So you're going to get 1 plus x over 4 to the 8 is going to be equal to 1 plus, and then you'll have 8c1, which we know is 8, 1 to the 7, which is just going to be 1, so I'm not going to bother to write that, and then you'll have times x over 4 plus 8c2, 1 to the 6, which is just going to be 1, not going to include that again, and then plus x over 4 all squared, and then 8c3, 1 to its power, not going to include that, times x over 4 all cubed. Remember, use the brackets because you need to cube both the top and bottom of that term. So tidying up, this is going to be 1 plus 8c1 is just 8, and divided by that 4 is going to be 2x plus 8c2 times, and then we need to square them top and bottom, so it's going to be 8c2 and then divided by 16, so that's going to be 7 over 4 x squared, and then 8c3 and divide that by 64, the 4 cubed on the bottom, that's going to be 7/8 x cubed. So that's part A. B, use your expansion to estimate the value of 1.0025 to the 8. So notice 2 to the 8 and 2 to the 8. So we've got to equate what's inside the bracket to 1.025. So 1 plus x over 4 has to equal 1.025. So I can see that x over 4 has to be the decimal part here, 0.025. So x cross multiplying, if we do 0.025 times 4, that's going to be 0.1. So what we have to feed into our expansion is that x is 0.1 or 1/10. So to get an estimate for 1.025 to the 8, we feed in that x is equal to 0.1 or 1/10. So this is going to be 1 plus 2 times 1/10, which is going to be 2/10, which is going to be 0.2 or 1/5, plus when x is 1/10, we need to square it, so that will be 1/100th, and then multiply it by the 7 over 4, it's going to be 7 over 400, and then the 1/10 all cubed, that's going to be 1,000th, multiplied by the 7/8 is going to be 7 over 8,000. So if you add all of those up, they all come to 1.218375. Now it's asking you to give an estimate up to 4 decimal places. So 1.025 to the 8 is approximately equal to 1.2184, giving it to 4 decimal places. And if you actually do 1.025 to the 8, that is exact to 4 decimal places. It's just not got the rest of it because we didn't have the other terms, but because the 0.1 that we were feeding in was so small, and you can imagine we're going to have x over 4 to the 4 and so on and so on, when you're feeding in that x is 1/10, and so we're going to have an even smaller fraction when we divide that by 4, raising fractions to the 4, they're going to be minimal additional terms to be added to the first 4 terms because of this x going in as a fraction and then dividing by 4 and raising it to powers. They're going to be very, very small. So it is a good approximation to 4 decimal places. So here's the next question. You can either pause the video and have a go yourself and then watch the solution, or just continue to watch and I'll go through it. So we've got 2 minus x over 16 all to the 9. So this is going to expand and give us 2 to the 9. But do it in the columns way so you can see that the patterns. The next term is going to be 9c1, 2 to the 8 and minus x over 16. The next one will be 9c2, 2 to the 7 minus x over 16 all squared. So doing it in the columns, because you know there's going to be 3 parts to each term, and then you can see the patterns happening. So 2 to the 9 is 512. 9c1, anything c1 is going to be 9 times 2 to the 8, and then multiply by minus x over 16. So you need to divide by 16, and because we've just got the single x, it's going to be minus, and that all comes out to be 144x. Then 9c2, 2 to the 7, then remembering to square, so it's going to be minus x all squared, that's going to be plus, and dividing it by 16 squared on your calculator, that comes out to be 18x squared. So that is the first 3 terms. We're only asked for the first 3 terms. Then we are told that f of x is a plus bx multiplied by this thing that we've just started to expand. And you're being told that in ascending powers of x, the coefficients of the terms are 128 is our constant term, and then 36x is our single power of x. So let's write a plus bx times the thing that we've just started to expand, which is going to be 512 minus 144x plus 18x squared plus dot 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 the rest of the expansion. Now to get this constant term, that's only going to come when we multiply these two together. So 512a is equal to 128, and a is going to be 128 divided by 512 is going to be a quarter. Find the value of b for part C. Now 36x is the coefficient of the x terms. You're going to get some x terms when you multiply the a times the minus 144. That will give you a single x because a is just a constant, but you're also going to get an x term when you're going to multiply these two pairs together. So we're going to have b times 512 minus 144a. They're all going to be what's going to be in front of x, so it's going to be those times x. So we already know that a is a quarter, so 512b minus 36, because a quarter of 144 is 36, equals 36, the coefficient of the x. So we just need to do 512b. Take that minus 36 to the other side is 72. So b is going to be 72 divided by 512, which comes out to be 9/64. So here's the next question. Have a go at. Pause the video, just continue to watch. Now I'm going to go through it. Prove that if we've got this expression here is less than this expansion, then x has to be bigger than 0. So you don't necessarily have to use the binomial expansion, but it's a quick way of cubing something. You can just write the 3 brackets next to each other and multiply them all out, but we're going to use the binomial expansion. So 1 plus 3x squared plus x cubed is going to be less than, when we expand 1 plus x all cubed, we're going to get 1 plus 3x squared plus x cubed, and we can see we've got 3 terms here are the same 3 terms there. So if we take them off both sides, you're going to get 0 is less than just this one remaining term, which is the 3x. Now if 0 has to be less than 3x, x can't be negative. If x is negative, 3 times a negative is going to be less than 0, because we're going to get a minus number. So this is only true when x is bigger than 0. So we've shown it and proved for part A. Part B, show by means of a counterexample that this inequality is not true for all x. So because in part A we've shown it's only true when x is bigger than 0, all we need to do to show a counterexample is choose x equal to 0 or x equals to a negative number. So you can do any of them. For a counterexample, you just need to find one example where it doesn't work. So I'm going to put in when x is equal to minus 1, you're going to have 1 plus 3 minus 1, and then on the right you're going to have 1 minus 1 all cubed. So on the left, 1 minus 1, you're just going to be left with 3, and that is actually bigger than 0. So when x equals minus 1, The 1 plus the 3x squared plus x cubed is actually the other way around, is bigger than 1 plus x all cubed. So this is our counterexample there. Thank you so much for watching. Please do like and subscribe because I do intend to be creating videos for each of the topics within the A-level syllabus. So do keep an eye out for some more videos and check those out. And I will see you on the next one.